Hey, this is Sam from VIM. Today I'm going to be going over LOD requirements for owners, facility management, and one of the most misunderstood aspects of LODs, LOD 500. So, how do we wrap our head around this, right? The first thing is we should learn about what an LOD is and what it's for. Also, we should mention LOD is going to be the most important for owners, and it's usually the ones that know the least about it. So if you're a BIM representative for an owner, you may already have this in mind, but I find this is one of the most misunderstood aspects of LOD 500, and Plannerly, or LOD Planner, has made an excellent article about this in 2019, which we'll be revisiting as well as many other documents. So let's get started. What's an LOD? Why does it matter? And what are the implications for the owners? So LOD is often thought of, well, first off, it's not level of detail, right? Level of detail would be the difference in the geometric level of information. Level of development is certainty about certain additional parameters. So for example, LOD 100, I may say, this is a phone. It's square and it's Android. Now the same model here with the same level of geometry at LOD 500 may be, okay, well, it's not just an Android phone, it's a Pixel 3 XL, and this is how much battery it has left. So the data got more precise, it got less generic, and the 3D model of the phone did not change. We just added more data, and we are now certain of the data. So LOD, the LODs are supposed to hold your hand during the processes like early design to advanced design to fabrication to construction to facility management. And every time you go from one phase to another, it usually changes hands. And this is where, if you don't plan it, you're going to have a lot of errors. You're going to have a lot of heritage, baggage, garbage, basically, that gets transferred between those LODs. And so it's very important for the owner to have a grasp of what's going on, ideally set up standards, ideally even set up international or national standards, or at least for your own company, set up some standards. Because you're the owner, right? Let's say you own 500 buildings and you want to count your doors. Well, what happens if that door is not categorized as a door? What happens if you want to look at the fire rating and you didn't give a standard, so the fire rating is written in 50 different parameters in your buildings, and it's never giving you the same data in the same way at the same location. So you need to set standards, you need to understand what's going on, and you have the most to gain from this because you're going to be using that building, that 3D model for 20, 30 plus years. So let's take another step back and figure out, when we set standards, we need to figure out, what are we doing, right? You don't just say, do the BIM, right? That's a recipe for disaster. You need to say, this is what I want to do for my BIM, and everything in our BIM execution plan is going to support that. So usually what we do is we start with BIM uses. If we look here, we have a table that has the 4 major parts of construction: planning, design, construction, and operation. Now for owners, obviously, what's going to be the most important is operation. Are you going to be doing renovation over time and you want to reuse your Revit models? How are you going to do that, right? Are you going to be doing IoT? What's your strategy for IoT? Are you going to be tracking your embodied and carbon usage over time so that you can prove your carbon usage and then transfer that building whenever you sell it? Well, you're going to need some certain parameters if you're going to be tracking carbon. Same thing for clash detection or estimation. A building where you don't do any clash detection is going to be a very different model. It's going to be cheaper if you don't do clash detection or you don't care about it, but you're going to have more costly issues on site. Same thing. If you kind of let people do estimation however they want, and the architect is not collaborating with the estimator, you're going to be paying a lot for that estimation, and it's going to be a nightmare for them because there's no collaborative processes saying, I'm going to put the right classification codes in my family so that the estimator doesn't have to redo my work every single week when they receive an update of the building. So start with your BIM usages before you determine the requirements of your LODs. And let's say, we look at a light fixture. We have an example here. We have a light fixture, and we can kind of set the requirements over time through those LODs and really determine what are we trying to do here, right? Am I going to do rendering? Am I going to do photometric analysis? Am I going to do proper estimation? So if we look at LOD 100, all we care here, it's a schematic design, right? So all we care is the approximate geometry. We want to count how many lights we have. And then maybe in early design, we add a couple requirements. We say, okay, well, now I also want the lamp type. Is it LED? Is it a theatrical light fixture? Is it just halogen, etc.? Then at LOD 300, well, approximate is no longer good enough now, right? We want to say, okay, well, you can't just have a giant box there. You need to actually show me the light fixture. Does it have a huge heat sink in the plenum in the ceiling that I'm going to have to care for clash detection? I want to have the accurate lumen value so that I can do photogrammetry and perhaps also rendering. I want to have the IES file so I can do photogrammetry and see what it's going to actually look like. I want to know which manufacturers are acceptable, which circuit it's on, if it's an emergency light or not. Now, when we look at a light fixture, unless it's a custom light fixture, we don't need an LED 400, right? We're going to buy it off the shelf. We're going to buy 500 of these lights. We're not going to go design 500 custom lights. So there's zero value in making a manufacturing model if we're not getting those built custom. So we're going to skip the LOD 400 altogether. And then it goes into construction. So in construction, you may want to start tracking some things, not in the Revit model, but perhaps in Power BI or some sort of other tracking tool. For example, the install date, right? You're not going to call the Revit modeler and say, okay, it's June 1st. Please mark that I've installed light 13374. That kind of data no longer needs to reside in Revit. It can be in Power BI. It can be an external data source, something that's going to be used for facility management. And when you're in construction, usually you want to start thinking about the as-built. Well, you definitely want to start thinking about the as-built, at least for operation, right? So it's no longer a generic light that could be this or this or that. It's a light that's been actually purchased that has a specific model, that has a specific clamp, that has a specific lumen, that has a specific intensity and IES file and shape and warranty and energy consumption. So those things are specific and they're no longer up in the air anymore, and we can determine what it is. Vice versa, there's probably a lot of parameters that are no longer useful. So a design light may be a light that can flex. It can be 8 foot, it can be 10 foot. It could be any light. It's a flexible light and it's got all of these parameters in there: width, height, length. And so those can change, and that's perfect for the designers that fits their needs. But at the end, well, we don't need those parameters anymore. We may need basic things like the length of the light, maybe, but the light is there, and we don't need to know the thickness of the casing. Nobody cares about that for the operation phase of things. And so same thing if you have a table, right? The table flexes, it can become length, width differences, have thicker legs, longer legs. Once you buy the actual table, nobody needs that data anymore. So that data is garbage. And so this is kind of how you marry the LODs, the parameters over time, and you decide what you need at each one of those phases, right? But as the owner, it's very important that you are clear and that you have standards as to what you want at the end. And if we go back to this article from LOD Planner here, this was published in 2019, and it's really not something that's understood enough. It's a fantastic article. And actually, this is a bit misleading, right? It talks about the LOD as if there's more and more geometric data added to it. And we really want to get out of that kind of thinking that we just kind of tack it on. Now, there's a great graphic here saying that the information just you kind of like tack on, you add more and more parameters over time. And then this is the actual graph of what we should be looking at. So it really shows that, yes, if you're going to go and manufacture stuff, you need to tack on more and more data. And then at LOD 500, when it comes to operation, the data requirements drop. We don't need the thickness of the metal anymore. We don't need the diameter of the leg tables, all of that stuff that we needed for a design model. So we can throw away a lot of those parameters and only focus on what the owner actually needs. Because when you look at one object and it has 50 parameters and half of them are empty and half of them are irrelevant, it just creates data noise. It makes your database much bigger. It's completely useless. It's sloppy, to be honest. And it just shows that there's not a rigor and a point in mind, really, during the whole process. You kind of are left with the garbage, the heritage of, whatever garbage the designers left in that file, or worse, if they just went on the internet and downloaded a family, or probably even worse, if they downloaded the family from the manufacturer. Those are often the worst families you can find. Okay, so let's look at a real example of a light fixture that has way too many parameters that would be completely irrelevant for LOD 500. So we're going to look at this light here, and we see it's present throughout the building, but we're going to look at a single instance. Now, first thing is the geometry of this light is way too complex for LOD 500, right? We don't care about this bump. We don't care about these sexy features. If we look in our kind of usages here at LOD 500, we no longer care about rendering presentations. We don't care about manufacturing. All we care about is showing the real product size, doing facility maintenance, doing clash detection, doing some lighting analysis. So none of those advanced rendering type of geometric visualizations are required. We can put a box there and it's going to be completely fine as long as it's not smaller than the actual shape of the light fixture. And just to be clear, like if we look at the worst offenders in terms of the geometry in our model, the lights are a huge offender. So this particular light is responsible for almost 1 million out of the 27 million triangles in this model, because there's almost 3,000 of these lights. So if we simplify it, it's going to make the entire model go faster, load faster online, etc. And same thing with this light, right? Nobody needs to have this entire heat sink and this wire, for example, or even these things. These can just be little blocks that show us, hey, if there's a pipe in there, it's going to be a problem, but nobody's doing a rendering inside of the ceiling. This level of geometry here really doesn't matter. This could have been just a very simple cylinder with a couple boxes to show where there could be interference problems. Okay, let's get back to this light fixture here, and we'll analyze the parameter and ask ourselves, do we care about this once we are doing facility management? Is this really something that is mandatory, or do we want to perhaps throw it away? So a big thing with parameter is, do I understand what it is, right? Am I using some sort of a non-universal acronym? Am I trying to shorten things and then somebody 10 years from now is going to look at it and not understand what it is? So optimized. What do you mean optimized? What does that even mean? This doesn't look optimized at all, right? So optimized, garbage. Apparent load, good. Default operation, elevation, well, I think it's a default parameter, so we can't get rid of it. Wattage comments, garbage. Lamp quantity with unit, garbage. URL, garbage. This is starting to be interesting, assuming it is not a design. Okay, so here's the other thing, right? With data quality comes the question of, Is this part of the design documentation where we kind of put a placeholder and it's not going to be what's actually built? Or is this actually the thing that they built, the actual model in here? So I have a feeling that this is the design. It's not the actual real data. So obviously the LOD requirements would kind of specify that. So if it's not actually H.E. Williams, well, wrong information is worse than no information, really. And so you'd want to really verify that in this case. Now we see a bunch of parameters here that are empty, more empty parameters. And so, a lot of these, like I said, just garbage, just completely useless and not useful. If you're a facility maintenance guy and you look at all these empty parameters, you're looking at noise. You don't know where the data that you actually care about is. So let's go in here. Coefficient of, okay, we don't really know what that means. There's no switch ID, there's no circuit number, there's no panel, tag 123, I don't know what that means. All of this is garbage parameters. This is a terrible thing, right? Bunch of garbage parameters all over the place. So this is what you're going to get as an owner if you don't tell the designers what you want and what is acceptable in the end model. You're going to get a bunch of garbage, empty parameters that are just adding noise to the data that you care about. You're not going to know if it's filled or not. And really, since you're the owner, you have the most to gain from all of this, right? You're going to be using this model for 10, 20 years. And when you are looking at 20 buildings next to each other, is that data talking to each other? Did you specify which parameter were mandatory to be filled out and to be present? Because if you didn't, you're just paying for a PDF creation that's going to be very expensive, and you're going to need to remodel all of this as soon as you sell it, as soon as there's a renovation. You're basically paying for something and throwing it in the garbage. If you just say, do the BIM, I don't care what you do, how you do it, you're throwing your money in the fire. So ideally, wake up, get a really good BIM consultant, hire some BIM people inside. Make sure you don't get bamboozled by your architect. There's a lot of fake BIM out there, and you're going to pay a lot if you go to a consultant or an architect that passes a wool over your eyes. There's a lot of predators out there with fake BIM that are looking to eat up all your money and throw up a bunch of useless garbage back at you. So make sure you have somebody you really trust for creating the BIM standards that are going to fit your needs. And then once you have those BIM standards, a tool like VIM in Power BI is the perfect tool to see if those BIM standards are being applied, right? You can give it the list of parameters to check, and is going to see if they're there, is going to see if they're properly there in the right category with the right shared parameters, etc., and is going to see if it's properly filled out with accurate data, and you'll be able to exploit that data once you know what you want. You verify that it's there, then you can exploit it. But if you just say, do the VIM, then give me the model, you're going to get garbage. You're going to get unusable garbage. All your money is going to go in the fire, and you're going to have to spend it all again. So equip yourself with a really talented little BIM army, and you're going to be saving money for 50 plus years during the whole life of the building. It'll be an easier building to sell because it'll come with a good BIM model. It'll be an easier building to renovate because the building model will be there for your renovation. And you're going to save a lot of money, right? If you have proper workflows for estimation, for clash detection, for renovations, you have an active plan instead of letting a bunch of random people decide what works for them and them only. So if you don't tell them what you need, they're going to care about themselves rather than you. And you're just going to get a PDF of the construction plan and a useless BIM model that you're going to have to pay more consultants to fix next time there's a renovation or next time you want to sell the building. So I hope this wasn't too overwhelming. It's a lot of data, but I think the main thing I want to really make sure of is that we don't think of LOD 500 as being this giant dump of data salad of information with no thinking about what the owner actually needs. When you go past LOD 300, 400, the requirements drop, right? You need simpler geometry and you need to get rid of all the parameters that are no longer relevant to the owner. So keep that in mind. Make sure you get amazing LOD matrices and BIM standards and BIM execution plans, and your project's going to go smoothly. You'll be able to verify it all along, and you'll be able to exploit it at the end in the exact way that you want for your BIM uses. All right, have a great day. Bye.